Bismillahirrahmanirrahim. My name is Javiz Tariq from Mechatronics Fall 20 Section B, and today I'm going to represent my project report. And our project supervisor is Umar Farooq, and our group member is Fatma Sad, Usama Anwar, Aruma Tanveer, and me. There are total 4 members, including me. So let's start with the video presentation. So first of all, I would like to discuss the team member role and the role which they perform. So team lead was Fatma Asad, which was provided us with guidance and instructions like how to do this work and how to modify our line follower robot. Our project manager is Aruma Tanveer, total planning or monitoring of the project, like how the project should going to work and monitoring the project, like how much is it done and any other thing. Now technical is me. In technical portion, I have to carry out the technical aspects of the project like soldering and interfacing the sensors, working them, setting the values and etc. And then comes the integrator and tester, which is Usama. Usama totally analyzed the whole project and report and created this report also. So let's start first of all our project preliminaries. Or proposal. Proposal was to design a line follower robot that can cover any given path in a minimum possible time, which also bring cost and efficiency. So we have to design a line follower robot which should follow a straight line, but we also have to keep the cost of this robot in our mind. Like we have to interface it with microcontroller and sensors and different types of sensors which we are told by our instructor. Upon reaching the point, it moved from point A to B, and upon reaching the point B, which is a T junction with all black line, it stops because all the 3 sensors in it were become on, and then robot will stop. So concept of this is generally the path is predefined and can be either visible like a black line or a white surface. So in our code, we just put values of IR sensor is equals to 1 if it follows the black line is equals to 1, and it follows the white line it equals to 0. So that's how we make our robot follow the line. And then after that the data is transmitted to logical circuit, hence the logic circuit is going to decide the proper commands and then it sends them to the driver. Thus the path will be followed by the line follower robot. So IR sensor read the analog data and then send it through Arduino to our motor driver, and then motor driver drives our motor and make the direction in which the robot was going. Now comes the estimated budget. So the budget for our robot is quite high and every member of the group contributed equally. So we have to bought a lot of things which will bring the cost of this robot a little bit high. I will discuss these things in the project report. So first of all is PCB board, then the base, wheels and motors, base wheels and wheels and motors attached to the base, then 3 IR sensors and a current sensor, voltage sensor for voltage sensing, SD card module in which SD encoder sends data through SD card and save it so that in future if any IR sensor is not working, or our SD card will transmit data through encoder and make the robot to turn whenever it's need to turn. Then the Bluetooth module, encoder, L298. Actually we use two L298 because the first one was destroyed or burned, so we use a second L298 motor driver. Then the interrupt button, and then resistors, jumper wires, glue, potentiometer, breadboard for prototyping, FeCl3 chemical for etching of the PCB board, male and female connections, soldering wire, solder, two Arduino Uno because we have just Arduino Uno. We have one and we bought another, so we have two Arduino Unos and we make two PCBs to make our line follower work. Double-sided tapes, 12-hour battery cells which were used to power the Arduino and motor driver, and then glue gun, which comes to total cost of 9,000 to 10,000 rupees. So, introduction of the line. A line follower robot is an autonomous robot which will be able to follow either a black or white line that is drawn on the surface consisting of a contrasting color. Means that if we use high quality IR sensors, it will able to either follow red, green or white, any color. But we use just basic IR sensor, so they just follow black or white line. The robot uses a group of infrared sensor to identify the line, which I just told, assisting the robot to stay on the track. The use of three sensors make its movement precise and flexible. The robot is driven by DC gear motors to control the movement of the wheels. Now robots are basically complete automatic machines. It start working when some sense something and decided to work according to the condition and stop by its own due to other condition or senses. So robots are always made for the ease of human being to work to minimize the load of a human being, we can say. So the objectives of this robot or the robot must be capable of following a line. It should be capable of taking various degrees of turn. It must allow calibrations of line darkness threshold. It must avoid any obstacles in a way. For this we use IR sensor, ultrasonic sensor. In if any obstacles comes to it, it moves away. Like it will take a turn which is 180 degrees turn. Speed of the robot should be controlled by Arduino L298 through PWM pins. So block diagram of this project is we used three IR sensors, one ultrasonic sensor, and then L298 motor driver, which you can see. Now we use two motors and two encoders which send data through second Arduino, and then the SD card is attached to the second Arduino so that encoder data will save to SD card. And then we used a current sensor, voltage sensor, interrupt and a Bluetooth module. So first of all, the equipment used, the chassis and the body. We adopted transparent plastic base for our line follower, which comes with fittings of sensors and every other component. So DC motor with wheels with a diameter of 65 millimeter, and then at the front and back supported metal rotating wheel which rotates 360 degrees. Chassis component of made of acrylic, have a mounting holes allow you to install all sensors, controllers and other things. To transparent universal platform allowing you to build a robot, agile line follower or fighting the robot. Now two DC drive motors with matching wheels, a caster ball for balance. You'll fit the rest in power supply, microcontroller board and motor controller. So we use the transparent chassis body and we mounted our PCB board on it. It consists of two motors, two wheels and a 360 wheel, the 360 turn wheel which comes up the forward. You can see this our base in this picture. Now we use two Arduino. Arduino is an open source computer hardware and software company. So ATmega 328 which was developed by AVR. It has specification of 8-bit CPU, 16 megahertz crystal or clock speed. It has 14 digital input and output pins. Each pin operates at 5 volt and can provide a maximum of 40 milliampere current. So the pull up of the resistors is 20 to 50 kilo ohms, which is disconnected by default. It has serial pin RX and transfer pin TX. So pin configuration, microcontroller external interrupt pins 2 and 3. These pins can be configured to trigger any interrupt or a low value or rising for falling edge or a change in value in 3. So PWM is 3, 5, 6, 9, 10 and 11. MOSI and MISO 13. So when pin 13 is low and it's off, along with the 14 digital pin, there are 6 analog input pins from A0 to A5. Each which provide 10 bits of resolution, or we can say 2 power exponent power 10 equals to 1 to 1024 different values. Now we come up to our Arduino. So it basically is like this. It has a chip, a 16 megahertz crystal, a power supply, direct in current power supply and analog. So here is the basic structure of the chip. This contains analog input from 0 to 5, VCC, ground and analog reference voltage, and 9, 10, 11 are PWM pins. 3, 5, 6 are also PWM pins, and then VCC ground, and from there from RX to digital pin 8. It contains a reset button also. Here is the data sheet. It has a power jack of 2.1 or 5.5 mm, USB connector, ITGA328P module, chip capacitor, high density, pin header connector. Then we come to ultrasonic sensor. An ultrasonic sensor is an instrument that measures the distance to an object through sound waves. Like it uh, throws signal from a trigger and echo pin. Signal collide and come back to ultrasonic sensor, and it detects the distance between two boundaries, or we can say two between point A and B. It works on a DC voltage of 5 volts and 15 milliampere of currents. The working frequency is 40 hertz, and maximum range is 4 meter, and the minimum range is 2 centimeter. Measuring angle of this is 15 degrees. Like if an object placed in between 0 to 15 degrees, the IR sensor, ultrasonic sensor will detect it. Otherwise, it won't. Trigger input signal dimensions are 45 into 20 into 15 millimeter total area. Then we used IR sensor. Now we actually use 3 IR sensor mounted in front of our robot to detect the path. So infrared sensor are used to find out position of a line follower with respect to robot position. Infrared sensor, the rays collide with the path which is to be followed, and then come back to this IR sensor which it detects and sends signal through Arduino. Then Arduino will drive a motor driver module. So basic circuit of this is IR LED contain photodriver module, photodiode, a receiver pin, LM358, a transistor, and then ground, and these are all connected to 5-volt ground and output. Now comes to motor driver module. A motor driver module is used to drive the motors. It has total of 6 pins. 2 of them were enabler, and other were digital pins. So it has a heat sink, and it works on 12 volt voltage, and 5 volt were enabler jumper were connected to Arduino because Arduino only can handle 5 volt of power. Analog and L298 motor module can control up to 4 DC motors. And then it has a data sheet of there are 2 enabler pins A and B, input pins, a ground, a VSS and a VCC, and then input 3 and input 4, and output 3 and output 4. An NC pin is not connected. Can be used to run 2 motors with same IC. Speed and direction is control is possible. Motor voltage VCC 2, VS 4.5 to 36 volt. Maximum peak motor current is 1.2 ampere, and maximum continuous motor current is 600 milliamperes. The motor we used 2 DC motors which contain some gear trains. These motors were driven through our L298 motor driver module. The conductor with the current usually produces magnetic field that will react with magnetic field produced by permanent magnet to make the motor rotate. It works on a basic magnetic field effect. Rated voltage is 3 to 6 volt DC. Continuous no load current. Minimum operating speed is 90 rpm at 3 volts and 200 rpm at 6 volts. In gear ratios contain 1:48. Encoder. The encoder sensor module is an electromechanical device that converts angular position of a motion of a shaft or axle to digital code. So encoder, which we used, basically we called it a U sensor. U sensor will detect the slits which were placed between the wheels. Whenever the slit moves, it count as one. So the number of times the slit moves, the encoder will count it and save the data to SD card, which we will later tell. So it has IR emitter, a detector, and it has couple characteristic. IR emitter is forward voltage and reverse leakage current. Detector is operating supply voltage, supply current, low level voltage, high level voltage, and all these things are given in data sheet. Now we use the SD card module. It's a common type of removable memory card used in phones. There are adapter card allow micro SD card to use in a full size SD card slot. It is especially useful for projects that require data logging. The Arduino can create a file in an SD card to write and save data using SD library. So we can actually save also data which the line follower follows the line and the data will be saved through Arduino into SD card. So it has been type ground VCC MISO MOSI master in slave or master out slave and SCK serial clock port and then CS chip selector. Now comes to Bluetooth module. It is used to connect small devices like mobile phones to using a short range wireless connection to exchange files. It uses a 2.5 GHz frequency band. The transfer rate the data can vary up to 1 megabytes per second and its range of 10 meters. Like it will only transmit data in up to 10 meters. It can HC05 module can be operating with 4 to 6 volt of power supply, and the data sheet of this is given. So it is a bidirectional uh, receiver and transfer pin, VSS and 3 volt programmable input or output line. Then comes to interrupt is a process by which Arduino steps a regular task to stopping and looping and go to interrupt function completes it uh, to complete its given interrupt function task. Interrupt usually blocks the Arduino for some time. It acts as a reset button, but it will not reset all the information. Only it will stop Arduino for a while and then carry on the process. Potentiometer. Potentiometer uses a three-terminal resistor. Potentiometer used to control voltage is used to control voltage like you have to slow or high control the speed of something, some motor. If you use potentiometers in that place, so potentiometer are really used directly to control significant power. Since the power is dissipated in potentiometer would be comparable to the power of in the control load. So we used this type of potentiometer which has three pins, fixed, variable, and two fixed and one variable and then voltage sensor. The voltage sensor is basically a voltage divider. Basically it consists on the principle of voltage divider consisting of two resistors with a frequency of 30 kilo ohm and 7.5 kilo ohm, 5 to 1 voltage divider. Hence the output voltage is reduced by factor of 5 for any input voltage. So it controls the voltage and it has pins of VCC, ground, and analog pin connected to analog pin of Arduino. 3 pins it contains. Input voltage 0 to 25. Voltage detecting range is 0.02445 to 25 volts. Analog voltage resolution is 0.00489 volts. Easy to use with microcontroller, small, cheap, and easily available. Current sensor. The ACS712 is based on the Hall effect of the current and it operates both on AC and DC. The sensor operates at 5 volt, produce analog voltage output proportional to measure current. It has the data sheet of VCC, V out, and I out. We has used three of each pin as we say. It can work on DC and AC voltages. Now working principle. A typical line follower board has two sets of motor, left motor and right motor. Both motor rotate on the basis of signal received through Arduino to motor driver. Now when the both right sensors sense white, then robot moves. In case when the out sensor or all of the out sensors are white, like no detecting, then robot will move forward, or mid sensor is detecting, then our robot moves forward. If the left sensor come to black line, then the robot will turn to the left side. If left sensor is detected, then robot will turn to left, and if the right sensor is on the black line, robot turn right. If the both sensors come to black line, which is T-shape as I have explained above, then the robot will stop, or it if it uh, you can say if ultrasonic sensor has an object in front of line follow robot, then it will take a 180 degrees turn. Those two cases when robot stop, or it will turn to 180 degrees and continue following the path. So this is the law, which is a truth table of this, which is a input output of movement of robot. If left and right, then left motor LM2 LM1, right motor RM1 RM2. If both are 0, then the robot is stop. If right sensor is 1, then right motor is moving and robot will turn right. If left sensor is 1, the right motor 1 is on, and then it will turn left. And then forward, for forward, both left and right sensor should be on. In this case, robot will move forward. So flow chart start, both sensors see black. If they are black, then the robot is in same speed will reverse. Only the left sensor see black, then turn left. If the right sensor on the right see black, then turn right. And this is the basic principle to follow the line for robot. Now this is the Proteus simulation of the our robot, which in which we use 3 IR sensor and Arduino Uno, ultrasonic sensor, SD card, and other things. Now define L0, define M1, R2, define trigger pin, and this is the code for all of our sensors, which we can see pin mode, output and input mode for ultrasonic sensor, for left and middle low and right high. This is how we write the code for ultrasonic sensor. Then delay of 700 microseconds. And now we have our PCB layouts. Actually we use two Arduino, so we need two PCB layouts for our project, which we'll explain in the block diagram. So line follower robot is an automobile that has ability to recognize its path, move and change the robot position toward the line in best way to remain in track. It is made to solve an unplanned authorized parking problem in the resident area using prototype valet parking robot. The line follower robot project challenge the group to cooperate, communicate, and explain the misunderstanding of electronics in mechanical system and their integration with programming, and successful completion of every task demonstrated the potential mechatronic system and positive group dynamic. So that's all from my side. So Allah Hafiz.